Hello.
Hello.
We are here to show you how to determine the molar mass of an unknown solid acid.
Through this process, we will also show you how to standardize a known base with an unknown molarity.
Let's begin with some background information. We will be using a process known as titration to determine the H plus concentration of an unknown acid, or OH minus concentration of an unknown base.
This can also be used to standardize the known base, NaOH, to determine its molarity. For this, we will be using potassium acid phthalate, known as KHP.
This acidic salt is used for standardizing bases because it is monoprotic and only has one ionizable H atom. This makes the calculations easier because one H minus ion reacts with one H plus ion to make H2O.
When using titration, it is important to use a pH indicator, such as phenolphthalein, known as PHP.
The PHP will then be used to determine when the endpoint has been reached. The endpoint is the qualitative point in which the pH is approximately 7, or neutral. The amount of basic solution used indicates how many moles of the base and the acid solutions were used to reach the pH of 7.
Once the concentration of the OH minus is determined in the NaOH, the molarity of the NaOH solution can be determined using stoichiometry. To determine the amount of NaOH present, one can determine the molarity by dividing by the volume of the solution.
Let's move on to the procedure. We must obtain 3 beakers for this experiment.
We must label these beakers as H2O, NaOH, and waste to prevent confusion because they are all colorless liquids. For the sake of preventing confusion, we will color the solutions in the beakers.
We must make the burette ready for use. First, wash the burette thoroughly with deionized H2O. Then we must coat the inside of the burette with NaOH to prevent a dissolution of the NaOH. Add about 5 milliliters of NaOH solution into the burette once the valve has been closed. Gently hold it horizontally and spin it slowly with the opening over the waste beaker. Do this for about 2 rotations or so. Make sure this is done over a sink in case of spillage. We now need to mask the KHP. When using the analytical balance to mask solids, one must use a weigh boat and zero it with the window.
Carefully place the burette in the burette clamp on the ring stand. Place the waste beaker underneath the burette and briefly open the valve on the burette to fill the tip.
Record the volume on the burette. We record a value of 0.40 milliliters. Now fill the boat with about 0.4 grams of KHP and record the exact mass of the KHP. We record a mass of 0.4258 grams.
Now dissolve the KHP into a 250 milliliter flask filled with about 75 milliliters of H2O by dropping acid into the flask. Add 3 drops of PHP into the flask. To maintain constant stirring, we will be using a stir plate.
Gently slide a magnet into the flask and place the stir plate underneath the burette. Place the flask on the stir plate below the burette and adjust the burette on the clamp so that the flask can be removed without hitting the burette.
Next, turn on the stir plate and set the speed to the lowest setting. We next pour the NaOH solution into the burette to a little over the 0 mark.
Now becomes a stoichiometry problem. Knowing the atomic mass of KHP, 204.22 grams per mole, we can convert our mass in grams of KHP into moles, which can then be converted into moles of NaOH. 0.002085 moles of NaOH is calculated from our first trial.
To calculate the volume of the solution used, we subtracted our initial volume from our final volume. 20.90 milliliters of NaOH were used in our first trial, which is also 0.02090 liters. Now we simply divide our moles by our liters to determine the molarity of the NaOH solution. For trial 1, we got a value of 0.09976 molar solution of NaOH.
We now repeat these calculations for all 3 trials. Once we determine the molarity of NaOH in each trial, we have to take the average of them to determine an accurate molarity. We calculated a molarity of 0.1019 molar NaOH.
Now we will calculate the molar mass of the unknown solid acid. We subtract our initial volume from our final volume of trial 1, which is 13.29 milliliters, and we multiply by the molarity of the solution to get the amount of moles of NaOH fused. Then we multiply by the coefficient ratio, which is 1 in this case, to get 0.001354 moles of HA acid.
We now divide the mass in grams by the calculated moles. 0.2665 grams divided by 0.001354 moles. We repeat these calculations for the remaining trials. We now take the average molar mass of the trials to determine an accurate molar mass. Our final answer was 204.86 grams per mole.
One source of error is over-titrating the solutions. The readings will indicate that a larger volume of the NaOH was used. As a result, the calculated molar mass of the unknown would have been lowered.
Another source of error is if one doesn't properly coat the burette with NaOH properly. The NaOH solution will then be diluted within the own burette. This dilution will then cause a larger volume of NaOH solution to be used, thus giving a lower calculated molarity of the NaOH. As a result, the calculated molar mass of the unknowns would have been lowered.